everyone. My name is Rashmi Poonia and you're watching Learn Science with Rashmi, where learning is easy and fun. So, what are we waiting for? Let's start. Our today's topic of the day is states of matter. Matter. First of all, we define that what exactly the matter means. Okay. Matter, everything in this world is made up of matter. Matter is anything, it could be anything that has mass or it occupies space. Okay, these are two things that are important. Anything that has mass, occupies space is termed as matter. For example, even a grain of sand is termed as matter because it doesn't matter how much small it is, but it is having mass and occupying space. Same way that even the atom, molecules, whatever they are actually considered, they are the particles of matter because they have mass as well as they occupy space. Moving forward, that the states of matter. In general, you must have studied that the different states of matter. And for your knowledge, I think you must have studied about 3 states of matter. That is solid, liquid, and gases. But shall I tell you an interesting fact? There are actually 5 states of matter. The 4th one is the plasma. And 5th is Bose-Einstein condensate. Okay. Bose-Einstein condensate. Okay. There are 5 states of matter. Let me show you a picture that how they appear. Okay. See, here within this picture, you could see all the 5 states of matter. That is the solid, the liquid, and gases. Here, this one is the plasma, and this is the Bose-Einstein condensate. Let's talk about the properties. Means all the properties of states of matter individually. Okay. First one is solids. There are certain points which you already know about solid. Is solids have fixed shape. Fixed shape, and they have a definite volume too. Right? Next is they cannot be compressed as the structure is rigid. Right? So the lattice is strong enough to hold it. So we can't compress them. We cannot compress. Number 3 means the particles, they are tightly packed. Okay. Let me show you the picture. See that here, this is an example, ice. Ice is an example of a solid state. So you could see there are 3 points which I have mentioned above, that they have fixed shape and volume. Even ice is having a fixed shape or volume. They cannot be compressed. Of course, we can't compress the ice, and the particles, they are tightly ahead with the second state of matter, that is liquid. Taking a most common example, that is of water. But of course, let's study the basics of what are the properties of liquid. Okay, the liquids, they have the fixed volume, but they do not have fixed shape. Okay, they do not have fixed shape. Okay, they flow. That's the only reason why we count them into fluids. Now, the next point about the liquids, that they occupy space, more space than solid, because they can flow. The third point, that being as they don't have a definite shape, so whichever container we use, they just take up the shape of that particular container. Okay, and you could see here the particles, they have too many spaces in it. Okay, so I could say that spaces, presence of spaces in between the particles. Okay, now coming to the third state of matter. What is it? That is gas. Okay, in general, we know about certain properties. That is that the gases, they don't have any fixed volume, they do not have any fixed shape. So I could write it as no shape. Okay, no volume. Second point, if I talk about that, they are highly compressible. Particles, they are highly, means they are very far from each other. So they do not have shape. As a result, they are highly compressible. Okay. Next thing, the particles are not arranged. Okay. Random presence means they are the particles, they are moving randomly. So I could say random motion. Okay. So these are certain general properties which you know about the solid, liquid, and gases. Let's talk about the properties in terms of kinetic theory of gases. Kinetic theory of okay, that is of particles. It is actually based on two things. Number one, kinetic theory of gases is more, first is the movement of the particles. And the next one is the average distance between the particles. Okay. Average distance between the particles. Okay. So let's coming to again the first state, that is the solid state. Right? Each solid state has a means perfect lattice. They are arranged in an organized way. They are arranged in such a way that the one particle can touch the nearest neighboring particle. That's why I said perfect lattice. Okay. So in this case, what exactly happened? That particles, they can't move around, but they can vibrate at their own position. But it doesn't mean that they don't vibrate. They are vibrating, but they vibrate at their position. Okay? Particles, they are closely packed, highly close to each other. Okay? And the particles, they have a perfect length. Being over there, they vibrate at their own position. In case of liquids, the particles, they are close to each other, but they can move past each other. They can slide over each other. Okay? So, as a result, as they can slide, this causes the random arrangement of liquid particles. Okay? Now, I hope you are understood that by the liquids, they do not have the fixed shape because the particle spaces are too much and they can pass over each other. They can slide it over each other, which causes a random arrangement. Now, coming to the third, that is your gases. Okay. In case of gases, the particles, they are means far apart from each other. Okay. They are not close. They are far apart. This causes the random movements. Random movement of the particles. They are moving in a high speed in different directions. And as a result, they do not have the perfect arrangement. Moreover, more frequent and means the particles movement is so high that they collide amongst each other. Okay? Collisions happen. Of course, more collisions happen. What would have means results in more pressure, wall pressure. Okay? Means more collisions, the particles, they just collide amongst each other, then more wall pressure is being created. Okay? Now coming to the next, that is your plasma. I'll just give you a gist of plasma too. What exactly the plasma is. Plasma is also a state of matter in which the particles, they have extremely high kinetic energy. Okay? Extreme high kinetic energy. Okay? And can you guess an example of it? Yes. Superheated stars. They are actually the charged particles. They are actually a perfect example of plasma. Okay? As superheated charged particle creates the ionization, and this ionization emits some sort of energy, and we call it as plasma. Okay. Now the next is Bose-Einstein condensate. This is the fifth state of matter. Okay. You know, children, that this state of matter was first discovered by Carl Wieman. Carl Wieman and his friend Eric Cornell, they cooled a sample of rubidium. Okay. And they cooled it to a nearly absolute zero. Okay. You know that it's impossible to reach it. But they cooled it with the help of a magnet and the laser. And they observed that the particles, there was a time when they stopped separating. They just clump up and start behaving, losing their own identity and start opting a new one. Okay. We also call as supercool atom. So it's just a small introduction about the Bose-Einstein condensate. Moving to your another topic, that is the change of state of matter. Changing the state of matter. You know that the matter has a tendency to change its state from solid to liquid and liquid to gas, and it's irreversible too. Okay, let's study how it happens. You can see this picture. Within this, you observe that this is the solid state. As soon as we provided the heat, okay, in this, the solid state or the ice, it melts to form the liquid state, okay. And if, means why it is happening, because the particles, as soon as we apply the heat, the particles, they vibrate faster, and a time comes when the bond is being broken up and it gets changed from solid to liquid state, okay. And the phenomena is known as melting. What we call it? Melting. If we keep on increasing the heat, a form of energy, then what happens? Eventually, the liquid gets changed into the gaseous state. And why it is happening? Because as the temperature rises, more and more particles gain energy to escape from one surface of the liquid to the one state of matter to the other one. Okay. And the phenomena is known as either the vaporization or evaporation. Okay. So now you can see how the change of state of matter occurs from solid to a gaseous state. The phenomena conversion of solid to liquid is termed as melting, and from liquid to gaseous state or the vapor state, we call it either the vaporization or evaporation. But it is a reversible process too. Like if we try to condense or bring the particles closer, then what would happen? They merge among each other and joins to form a bigger one. That is known as, the process is known as condensation. You can see in this diagram, when we cool the steam, so particles, they come closer among each other and get changed into from liquid vapor state to the liquid state. In the same way, if we continue giving more, you can say the freezing, you can say more condensation to it, then they solidify to change from liquid state to solid state. If we keep on decreasing their energy, okay, by cooling method, and the process is known as solidification. Okay. You know, children, this is all about that, how the things were being changed from solid to liquid, liquid to gaseous. But you know that there is one more method in which this in between state doesn't come up. Let's take an example of an incense stick or a naphthalene ball. Okay. What you have observed, that incense stick, we call it as agarbatti also. Okay. When we lit the incense stick, what happens? The solid get changed directly into the gaseous form. Okay. So this phenomena or this process is known as sublimation. Okay. The process in which the solid state get directly converted into gaseous state. Another example of this is the naphthalene balls. Okay. When we put the naphthalene ball, after some time, it gets changed into, it gets vaporized with the passage of time. I hope now the conversion of state of matter is being clear to you. Let's move forward. That how the energy changes during the state of matter. Let's talk about it. Energy change during change of state. I'm going to show you a graph that what exactly is happening in it. Okay, just give me a moment. You can see a graph. This graph is actually the heating curve of a solid. This graph is representing what? The heating curve of solids. Okay. Now you could see what is happening in this. As soon as when we monitor the temperature of a solid, when we give the heat, it starts melting it down. Okay. The temperature rise, the particles, they vibrate, and at time comes when they get melted. Okay. But now you could see there is a saturation point. The temperature stop rising at the solid's melting point. This one. It remains constant until all the solid particles were being melted. You know why? Because at its melting point, the energy provided, you can see that we are providing the constant energy. The energy provided in the heating solid is being absorbed by all the particles. Okay. And is being utilized to break the bond. As a result, there is a constant or a saturated graph. Okay. As soon as all of the particles, they were being converted into the, means they were being melted. Then again, there is a steep rise from solid to liquid and liquid to the gaseous state. So, I hope now it is clear to you that what type of curve we obtain during the melting point of solid. So, that's all for today. I hope you understood today's topic. We'll meet you soon. Thank you very much. Bye-bye.